Welcome to the Tool Lending Library at the Smart Building Center, an energy efficiency innovation space for commercial, institutional, and industrial building operations. Our focus is where smart meets comfort, safety, and efficiency. And we offer state-of-the-art training and meeting spaces, educational resources such as this training video, and our Tool Lending Library offers a wide spectrum of diagnostic and monitoring tools available for free. So to create an account and check out our tools, go ahead and visit our website at smartbuildingscenter.org. So here we are in the Smart Building Center conference room, and in the context of COVID, pandemic, and occupying our buildings, of course it's important to practice certain protocols like mask wearing, social distancing, and also of utmost importance is providing enough outside fresh air to dilute any potential viral particles. So one way that we can determine how much fresh air we're bringing into a space is by comparing it to CO2 levels for outside air, which typically are about 400 parts per million of CO2. And we refer to that as atmospheric or ambient levels. So we can use that number as an indirect way to estimate how much fresh air we're bringing into a space. So here I have set up a Telair 7001 CO2 monitor, and it is attached to a Hobo 4-channel analog data logger, which is logging the data. And in another video called Verifying Ventilation System Effectiveness, we go into detail about how to configure these loggers. Now, typically under normal conditions, ASHRAE recommends that we have no higher than 700 above atmospheric levels for adequate fresh air flow before occupants start feeling drowsy or become less productive. So that would put us around 1100 parts per million. However, during pandemic conditions, we want to keep our CO2 levels much lower than that. We want to get as close to atmospheric levels as possible while still being able to maintain the desired condition temperature. So let's look at some actual CO2 data. Since the Smart Building Center has been largely unoccupied during the pandemic, I wanted to look at some data from a facility that has been occupied. In this case, a commercial gym. And so I've pulled in the data to HoboWare Pro, generated this graph that shows CO2 levels for a 2-week period in January. Now we can assume in January we're not economizing. And that's important to note because if you are economizing while you're taking data and then analyzing it, it's good to be aware of that because you will naturally see lower CO2 levels due to the increase in fresh air you're bringing in. And you can't always assume that you'll always be ventilating with the same fresh air rate at different times of the year. So this data shows we're in the low range around, a little above 400. And it looks like we're peaking. We have a few peaks here, a little above 700 or so parts per million. We actually have some statistic info over here. We can when we expand this drop down, we can see we have about a 400 minimum and maximum 735. And our average is about 513. So averaging 500 seems great, but what we really want to be concerned with are these peaks. And so it's good to look at a little closer and see how long those peaks are lasting. So we can take our crosshair tool up here and use it to create this red line, which will scroll through. You can scroll across the graph and it will scroll through the raw data up here on the upper left corner. So I'm going to look at this peak over here and I'm seeing that we're let's see, around 4 o'clock, we're down near 400, 428. And then
we are slowly rising. As we scroll over, we can see that this data is, the CO2 levels are increasing till we get to about 930, and then we peak at around 700 parts per million. Then we have another decline of CO2 levels. So we could assume that this being an exercise facility, maybe there's a very aerobic class or series of classes happening during that time period where people are in the space expelling a higher amount of CO2. And so a good strategy is to measure and then adjust your ventilation levels by adjusting your outside air damper, and then measure and adjust again. And keeping in mind that the higher your ventilation levels, the higher your energy use, not only because of fan energy, but because you have to condition all of that air. For example, take an incremental approach, maybe adjust the outside air damper by about 10%, measure again, see if you're within acceptable levels. If your building automation system or control system will allow you to adjust the outside damper, air damper during those periods where you know you have an increase during a specific class period, for example, then that might be one strategy to ventilate more fresh air while still keeping your energy efficiency in check. It's also important to measure CO2 levels in multiple spaces in a building, especially shared workspaces, conference rooms, cafeterias, etc. Now, another idea to keep in mind is that the direction of airflow in a space can be as important as the amount of fresh air. So checking flow patterns in a room can be accomplished using other tools from the tool library, such as the smoke pencil or airflow meters. And then you can use this information to adjust diffusers or reposition workspaces in order to minimize the chance that occupants are downstream from an infected person.
Okay, so we've seen how monitoring CO2 levels can help us approximate how well we're ventilating a space and diluting the air so that we can mitigate the spread of infectious disease particles. And this is just one of the many tools we have available in our tool library, and as well as many other resources such as more video tutorials and other educational resources. So check us out at www.smartbuildingscenter.org.